Okay, welcome everybody. In this video, we're going to talk primarily about exponents of 0, and also I'll go back over exponents of 1, what happens when I have an exponent of 1. I'm going to break this down into two separate videos just to kind of keep the segments a little bit shorter and hopefully to avoid a little bit of confusion with the work. So let's tackle exponents of 0 and 1s first. And I'm going to use examples with patterns of numbers. If I write 2 to the 4th power, that's the exponential form. We should know by now, it's expected, if you're looking at this lesson, it's expected that you know I can write that in what we call expanded notation as, I'm going to include the 1, but 2 times 2 times 2 times 2. Now, you might say, why is that 1 there? Why do we have to write it? Because anything times 1 is itself. Well, that's going to be important when we get down towards our special rules for exponents. So, this is what we call expanded notation. And if we simplified this and write it in standard form, that means I take 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16. So standard form would be 16. Now, as we go through the process, I'm going to work my way down an exponent. So I'm going to go down an exponent. 4 is here, 3, I'm going to go 2, 1, so on and so forth. Look what happens to the pattern in expanded notation, and then try to see the pattern with our standard notation as well. So writing 2 to the 3rd in expanded notation, 1 times 2 times 2, which gives me 1 times 2 is 2, times 2 is 2, 4, times 2 is 8. Okay. 2 to the 2nd, I get 1 times 2 times 2, which gives me 4. And then 2 to the 1. What happens when I get 2 to the 1? Well, if you've been following this pattern, the number of 2's keeps dropping off by 1. Each time I go down, I lose one of my 2's. So if I write this out, 1 times, I only have 1 2, which is 2. And if I look over here, what's happening? I'm really dividing each of these by 2. So over here to the right, I'm going to write the general rule. Any exponent or any variable raised or any number raised to the power of 1 is simply itself. 2 to the power of 1 is simply 2. And that's our first rule. Now I'm kind of hoping you understood that already, but we'll touch back on that rule. It was along the way. So let's continue moving down an exponent. Our next exponent down would be 2 to the 0. Well, following this pattern, I'm losing a 2 each time, so all that's left is 1. And look what happens when I divide 2 by 2, following this pattern over here. 2 divided by 2 is just 1. There's our 0 exponent rule. Anything to the 0 power is simply 1. Anything at all. Okay? All right, so I'm going to go to a new slide, and I'm going to put a couple sample problems. I'd like you, as I put the sample problems up there, these you can probably do in your head a little bit, but I prefer you write them down on a piece of paper next to your notes as examples. All right. Okay, so now that we have that those rules kind of identified, let's do a little bit of work with them. Let's go to a next slide. Okay, so I'm going to clear this slide. If at any time you need to stop the video, go back and kind of look at these two rules, please feel free to do so. Hopefully, if you just tag those down on a piece of paper on your notes, that'll probably be more helpful to you. Okay, so let's start putting this in a little bit of context. If I have, let's say, 2 to the 0 power, or 2 to the 1st power, how do you think those are going to simplify using the two rules that we just talked about? Go ahead and pause the video, think about it for a second, and then I'm going to continue. When you hit play, I'm going to show you the answer. So 2 to the 0, we said before, anything raised to the 0 power is going to be simply 1. Anything raised to the first power is simply going to be itself. 2 to the first power is just going to be 2. Pretty straightforward when these guys are all by themselves. Now let's go and let's mix up some operations. Let's throw a little bit of multiplication in there. Okay, so now instead of just one term, I'm going to have 3 times 2 to the 0, and let's go 3 times 2 to the first power. When you start having other operations involved, you've got to remember the order of operations. PEMDAS, parentheses come first, there are no parentheses on either one of these. Then we have the exponents. So I have to simplify the exponent first before I can do the multiplication. So working downward, I'm going to do my exponent, 2 to the 0, and 2 to the 0 is 1. If I bring down the 3 times 1, that's going to give me 3 times 1. That simplifies to 3. Over here, if I do the exponent first, 2 to the first power is just 2. That changes this to 3 times 2. And when I simplify that, I get 6. So when you're doing problems with exponents and other operations, make sure that you do your exponents first as much as you can, and then perform the multiplication or division or whatever else might be there. Go ahead, stop the video, go ahead and try the 2 or 3 entrance ticket problems. If you think you got a handle on this, go ahead and watch the next video in this lesson where we deal with negative exponents. Thank you.